Welcome back, Hononegah Algebra 1 students. We're going to do section 1.3 today. Solving equations with variables on both sides of the problem. So basically, we're adding more steps. You'll find throughout your mathematical career that a lot of times, basically what math does is adds more steps. You're able to solve bigger problems by taking more steps, but eventually you're always going to get back down to what we have done in this class already, which is one step and kind of two-step solving. So here we go. 10 minus 4x equals negative 9x. Anytime I see an x on both sides from the question, I want to get the x's on the same side of the problem. How do I do that? Well, I would do the inverse operation, or in this case, adding 4x to get both the x's on the same side. Now, technically speaking, you could have gone either way, but I always like, if there's only a letter on one side, I want to get everything on that side. So negative 9x plus 4x would be negative 5x. And then I'm back to a one-step problem. Since it's negative 5 times x, I'm going to divide both sides by negative 5 and get x to equal negative 2. Again, if you want to check your solution, you would put negative 2 in for x. So 10 minus 4 times negative 2 should equal negative 9 times negative 2, and it does. Now, this goes back to what we talked about in section 1-2, distributing 3 times 3x and 3 times negative 4. So I distribute it on the left-hand side. I'm going to distribute a fraction. Do not let fractions bother you. Okay, you can use a calculator. 1/4 times 32x would be 8x. 1/4 times 56 would be 14. Now, I see an x on both sides of the problem. The first thing I should do is combine like terms, or in this case, get the x's on the same side. So I'm going to subtract 8x. That will get both x's on the left here. So 9x minus 8x is 1x. And now I'm down to a question that I've solved previously. Inverse operation, I would add 12 to both sides, and x would equal 26. Next one, distributing a fraction again. Okay, do not be alarmed. Negative 3/4 times 8 is negative 6n. Negative 3/4 times 12 is negative 9. Distributing on the other side, 3n minus 9. All right, I see an n on both sides of the problem. You can go either way. Somebody in the class might say, I need to subtract 3n to get the n's on the left. Somebody else in the class might say, I'm going to add 6n to get the n's on the right. Both people are correct. I'm going to go ahead and subtract 3n to get them both on the left-hand side there. Now, do not be alarmed by this situation. I will be honest, there will be a bunch of people on the test that will get this exact question wrong. Dividing by negative 9 to both sides, 0 divided by any number is always 0. So again, it's okay to have a 0 on top. It is not okay to have a 0 on the bottom, and that's a whole nother conversation. But for right now, okay, if you have a 0 on top and you're dividing by a number, make sure that you put 0 as the correct answer. Pause for a second. Try the next one by yourself. And I'm back. So now, make sure that you double check that you did this right. So we're going to distribute. I, C, and H on both sides of the problem. So you're going to add 5H. Inverse operations, I'm going to add 2 to both sides. Do not be alarmed. You end up getting a fractional answer, 3/8. Questions, make sure you talk to your teacher. All right, here we go. More multi-step. Special solutions. Anytime when you go to solve and the variable ends up canceling out, so you no longer have a variable in the problem, it's either going to be infinitely many solutions, which I will allow you to abbreviate as IMS, or no solution. Okay, which I will let you abbreviate if you want to with a 0 with a line through it. So infinitely many solutions and no solution. All right, so here we go. I go to solve this. It looks like every other question. I'm going to distribute the 3 on the outside. I go to subtract 15x from both sides. Uh-oh. This side is 2, and this side, the x is gone. I get 0. There is no longer a variable in the question. If there's no longer a variable in the question, it's either no solution or infinitely many solutions, because 2 does not equal 0. Okay, this situation is impossible. 2 does not equal 0. You would put no solution. Next one. Again, looks like any other question that I might have given you. You're going to distribute. I go to add 8y to both sides to get the y's on the same side. Uh-oh, the y's cancel on one side, and the y's also cancel on the other. Negative 2 does equal negative 2. So those numbers are the same on either side. So yes, this is a true statement. Therefore, there is infinitely many solutions to this. Hit pause, try the next two by yourself, and see what you get. All right, welcome back. Let's see how this goes. Let's see if you got the right answer. I'm going to distribute. There's a parenthesis. I'm going to add 4p to both sides. And uh-oh, p's cancel on both sides. Remember, this is a no solution or an infinitely many solution. Because 4 does equal 4, you would write infinitely many solutions. Next one. All right, there's a lot of little steps to this one. I see a 6m and a 1m. So 6m minus 1m is 5m. So I added like terms on the left-hand side. Distributing on the right-hand side. A fraction. Okay, and most of you are not going to like this little situation. 5/6 times negative 10 would be 25 thirds. Now, you can put that as a decimal. You just don't need to. It's 56th, which reduces. I'm going to subtract 5m. Uh-oh. It cancels out on both sides. 0 does not equal negative 25 thirds. So these two are not equal to each other, and so therefore there is no solution. So now a little bit of summary on how to solve. First, simplify, meaning add any like terms. Okay, get the x's or whatever variable you're dealing with on the same side of the problem, and then isolate x like you've done previously by using inverse operations. A boat leaves New Orleans and travels upstream on a Mississippi River for 4 hours. The return trip takes 2.8 hours because the boat travels 3 miles per hour faster downstream due to the current. How far does the boat travel upstream? Now, we used this equation earlier in a previous lesson when we talked about finding the speed of something. So the distance is equal to rate times time. So the distance going one direction is the same as the distance going the other. So a little bit of maneuvering here. The rate and time going one direction needs to equal the rate and time going the other direction. So now it took 4 hours going one way at an x rate, and the other way it took 2.8 hours going at a rate that's 3 miles an hour faster. So the first one we went x, and the other one you went x plus 3. Distribute. So 2.8 times, whoops. For some reason, my board went messed up there. So let me try this again. You're going to distribute the 2.8. So 4x equals 2.8x plus, now again, some of you might need to use a calculator here, 8.4. Subtract 2.8x to get the x's on the same side. So now 1.2x equals 8.4. Divide by 1.2, and x is equal to 7. It's a word problem. So what do we need to write as a label here? How far does the boat travel? Excuse me, that is the rate, x. Okay, I apologize. That is the rate. We just found x, the rate. How far did the boat actually travel? Remember, we went 7 miles an hour for 4 hours. Gets me 28 miles. So again, some of you are going to be a little bit confused on that, but what we solved for was the actual rate, and then what we actually were asked was how far does the boat travel. So again, there's a couple added steps there that might be a little bit confusing to people. How do you find distance when you travel? Distance equal to rate times time. Think about this logically. If I'm going 70 miles an hour down the interstate for 2 hours, then I'm going to travel 140 miles because I'm going to take my rate times my time, and that would give me my total distance. What does it mean to isolate the variable? It means getting the x by itself, or the variable by itself. Your homework assignment, if you have any questions, please make sure that you contact your teacher, and good luck.